Right. Let's let that load up here. So what you're thinking of when you put 90 here is a tangent to a circle that goes to the
Mhm.
radius is 90, but the center's
Oh,
there somewhere.
it's a chord.
Yeah, so you actually have to find this arc length that I'll put in, measure of this arc length in red here, which ends up
Mhm.
being 150 degrees because you subtracted from uh
210,
yeah, from 210.
260.
Now, do you remember how to find this one here?
Uh, s- Angle X.
Yes.
Well, no, not really.
Okay. I need to double check what it is. This is the odd one.
Mhm.
The tangent chord theorem, I think. All right, so it's a fourth of that. It's 180. I want to say it's half of 150, but I want to double check this before I give you. Do you happen to have the answers to this to
I
these?
don't.
You don't.
Oh,
Okay.
actually, I think I might.
Why don't you check and see if it's 75 because that will help me to tell you if because I don't want to tell you the wrong thing at this point. Um,
Yeah. No, I don't know the answers to that.
all right, so it is half of that. So it is so this x is one half of 50, 150. I just double checked that there.
Oh, okay. So X is gonna be 75. Cool. And then 15.
Okay, 15 here. Let me snip this in. The next few should go much faster here. So 15. There is a formula here. The scenario here is you've got a point outside the circle, and you've got what I call it little m, and then big M. And so it doesn't matter. Like in this case, it's a secant and a secant line, meaning it touches it in two places. It could be a tangent and a tangent. The value of x here is always the big M minus the little m over 2. So the big measure, the little measure subtracted.
For problems like that, it's always gonna be that formula.
Yeah, and it also applies, what I was trying to say is it also applies to the tangent problem. And it also applies if you've got one tangent and one secant.
Okay.
And it's a general purpose formula. Sometimes they don't show you all of them, but it works for all of them. So that ends up being 30
So,
degrees. Um, so we'll come back to 16. Let's do 17 next. Because
okay.
it's more like 15.
So
This is
X is
actually,
gonna be 30.
yes,
Okay.
yes.
So 17.
So this is kind of a working backwards problem. They
Mhm.
give you the value of x. It's still m, big M, let us a little m over 2. This is big M, this is little m. So in your problem, your x is 30 and big M is unknown, minus 45 divided by 2. So you have to solve for y here. So you can maybe guess and check, but if I think you're probably familiar with solving this, you're going to multiply both sides by 2. Oops.
Mhm. I got Y is 105
Yes.
degrees.
Good. Yeah, the degrees are important there. Let's actually do 18 because
Like 14.
yeah, it's like 14. So it's just going backward. You have to find the measure of that arc first.
So 40 times 2 is 80. And then 360 minus 80.
You got it. there's not really a ton of work to show, so you may want to ask your instructor like what they want, because
Mm-hmm.
if you just write down the correct answer, is that enough, or we get back to you.
280 degrees.
Yes, very good. Okay, so all of those problems, actually, well, let me backtrack. This one is now an angle inside the circle. These are kind of like the ones we were looking at last time. I still use this designation of like little m and big M and X, but X is now the average. It's little m plus big M
Um,
over 2.
A plus, no. Okay, so 6C plus 190. 250.
Yeah.
Divided by 2. 125
Good.
degrees.
All right. I guess we can go to 19 now.
Mm-hmm.
All right. All right. The diameter of the circle is 12 feet. That means the radius is 6. Usually you need the radius more than the diameter. It says the arc from D to C is 40 degrees. Find the exact length CD, exact length of CD. So CD is like a walk around the circle. And if you were to go
Mm-hmm.
all the way around, that would be the circumference. The circumference is you go all the way around, that's 2 pi r. I guess you could go pi times diameter. I didn't realize that's what I was asking for. But that's if you go all the way around. If you don't go all the way around, it's the angle, it's how much you go around divided by 360.
Uh-huh.
Okay, so it's a little bit of a modification to this formula. It's no longer the circumference. It's what's called an S, or an arc length. So you take that angle, that 40, divided by 360, and you multiply it by 2 times pi times your radius, which is 6. Now, if you're going to go to your calculator, leave the pi out. Just put the pi off to the side and go 40 over 360 times 2 times 6. And your answer will just contain a pi in it.
Times 2 times 6. 40 divided by 360 times 2 times, whoops. Like 1.3 pi.
So 4 thirds pi. So when it says exact, you have to convert that to a fraction. So 4 thirds is 1.3 repeating. We also need to add in a units here, which is feet.
How do we do that again to convert them into a fraction?
For TIE3, it's math, enter, and it'll say 2 frac, and then you hit enter again.
Math, enter. Enter. Just math, enter.
Yeah.
With the decimal.
Well, you kind of want to do it from your answer. Let me show you here. We could pull this up here. Is that up? Yeah, there it is. Okay. So let's just say we did what you have here, 40 divided by 360. Your calculator can do it all at once. Times 2 times 6. You'd enter, and you got that number, right?
Uh-huh.
That's where you go math for 2 frac is what that is. Enter, 4 thirds, like that.
Okay.
So let me snip that in case you want to look at that later. You want to get comfortable with putting it all into the calculator at one time.
Mm-hmm.
All right, so back to the other screen here. Any questions on that before we move to 20?
Pi feet. No.
Okay. So you really need to know this formula. They might have presented it to you slightly differently in class. I like this one better because it's more intuitive. You're used to circumference and you just add this little multiplier on the outside based on
Mhm.
how far around the circle you're going. Okay, find the length DC. If the radius of the circle is 14 feet, round to the nearest hundredth. So again, the circumference is 2 pi r, but we're not going all the way around. We're going some angle at a 360. That's your arc length there. Okay. Okay, so you're gonna go, what are you here? 46.
46 over 360 times 2 times 14.
Yeah, and just leave that pi. Oh, I'm sorry. Actually, this one says round to the nearest hundredth. So just throw it all in the calculator, 2 decimal places on that.
Oh.
Let me know your answer here.
Uh, 11.24.
Yes, and then what are the units that go along with that?
Degrees. Or no. Feet.
Feet. It's a distance. It's like, hey, how far did you walk? 11.24 feet.
Yes. 21.
Let me just, the next grouping of problems here switches to lengths. Okay, that's fine. We'll just do them in order here. I was thinking maybe there's a better order, but there is not. All right, 21 here. Snip that in. Take a look at that. All right, so if BF is 9, EF is 12, FD is 4, determine X. So the relationship is if you've got 2 chords in a circle, A, B, C, and D, A times B equals C times D.
Oh, yeah.
I don't know why that works, but it just does. It just does in these problems. It's kind of a mystery to me that would work out so nicely. I think it has to do with similar triangles and some stuff like that. But you got to take 12 times X equals 9 times 4.
So 36 divided by 12.
And then they go a bit further here. They want you to find the full length of one of the chords.
X equals 3. So CE is going to be 15. Nice.
All right, is 22 the best one to start with? I guess. Okay, there's 3 different types of problems you'll see where they're asking for lengths outside the circle. This is the tangent secant.
Mm-hmm.
And one of the things that you need is the whole length. So this one is 4 plus 8, 12. Because the formula here is it's always part times whole equals part times whole. And so when I say part, the part is this shorter one. So in this one here, it's 4 times 12 equals, your part is X and your whole is X in the tangent one. They're the same.
Well, did you say that we could use big N minus little n over 2?
This is lengths. What you're talking
Okay.
about is for arcs, measure of arcs. And so they're in the same part of the course. So it's could be very a little bit confusing.
Oh. so that it's part times whole.
So in the case of the tangent, the part and the whole are the same.
Four x so equals x times. Oh yeah, x times x equals x squared.
Do you remember how to reduce a square root like this that is not perfect? You have to break it apart into a prime factorization. Start with 2, 2 and 24. Try 2 again, 2 and 12. Try 2 again, 2 and 6. Try 2 again. And you look for pairs. So there's a pair of 2s. Pair of 2s for each pair. You can bring one out.
Mm-hmm.
So it's 2 times 2.
There's a way to do this. I don't have my calculator on me. I lent it to a friend, but you go like y equals, right, and then like 48 or 48 divided by x, and then table, and it gives you like all like the things.
I mean, that sounds like a little bit of a shortcut here that may work some of the times. I'm suggesting, I mean, this isn't all that difficult if you think you can agree with that. But you have to know the algorithm, which is you look for pairs, the pairs come out, the non-pairs stay in.
Yeah.
I mean, there's a calculator for everything, right? You're being tested on your ability to do this for your knowledge of this.
Yeah.
Okay, so sometimes here you just find x. Sometimes they want you to like find the whole length of either the tangent or the secant. This does not ask for that, but it could.
And then I'll just plug in.
Oh no, that's it. This is it. That's your answer. There's nothing more to do.
Yeah. For one of those problems, I would just plug in x.
Yes.
Okay.
All right. So we got 23 here. All right. So again, part times whole.
So
equals part times whole.
K times 9k.
So it's k plus 9 because you're adding them together.
Oh.
K times k plus 9. Is that clear why that is?
Mm-hmm.
Okay.
9 plus k is equal to 6 times 6.
So you're going to subtract, but from both sides, you get k squared plus 9k minus 36.
Why is it k squared?
K times k. So they both have a power of 1. Add the exponents.
Distribute.
So two numbers that multiply to minus 36, but add to positive 9. It's going to either be 12 and minus 3 or minus 12 and 3. Do either of those work here?
Sorry. Why did we equal it to 0?
Because you're subtracting 36 from both sides. The only way to solve a quadratic is to get everything on one side, typically.
Oh, okay. 36 equals 0. And then what's that thing down there?
Okay.
Yeah.
So this has been a while. To factor this, you have to find two numbers that multiply to minus 36, but add to positive 9. You would have seen that last year in Algebra 1. It's like I was speaking Japanese to you, maybe. All right, so it's like -1 and 36. Do you agree that those multiply to -36?
Yeah.
But do they add up to 9?
No.
No, they're way off. Okay. 1 and -36, that doesn't work either. Then you try -2 and 18.
Yeah.
2 and -18. then you keep going down this list. Now I'll do the list here, but you want to quickly find it, which could be a while here. And then -6 and 6. There should be, right? Famous last words. There should be a pair that works. Hopefully you can see it here. It has to add to +9 up here.
Oh, okay, I remember that. I remember doing it. I don't really. So then.
So the one that works here is -3 and +12, which means you'll write k -3, k plus 12. And do you remember what to do from this point?
-3. Foil.
No, if you foil, you'll go backwards.
Oh.
Right, you don't get off the plane and get right back on. You gotta do something different here. You gotta set them each equal to 0. K -3 equal to 0. K plus 12 equal to 0. So k is 3 and k is -12. Now, do either of those appear wrong based on the context of this problem?
K plus 12 equals 0. K equals -12. K.
Like, can a distance be a length be negative?
No.
No, so this one's out. You could get more than one solution, but this one's out. So k is 3. And sometimes, like I said, they ask you for the like let's say this was a SAT, they might ask you for the length of AT.
Oh. And
But
then
they don't.
you would. Okay.
Yeah, you put the k value back in. So don't get too hung up on this. You might ask your teacher, hey, am I going to need to factor, or is this just on a homework? And hopefully they say no.
What is that called? That when we're doing the factors of a number from that.
It's factoring, but there's 5 types of factoring. So I call this the A equals 1 type, which is a pretty standard reference if you're going to your teacher and asking.
Okay. Sounds good. It's a 24. Neither of these two are tangents. Both are.
Yeah, let me get it pulled up here. All right, so the whole I like to label the whole kind of off to the side 18. That's 14 plus 4, which may not seem right to scale, but could be okay. And then this one is 9 plus z. So your part times whole is 14 times 18 for the top one equals 9 times 9 plus z on the bottom one there. All right, so if you don't have a calculator here, let me just drop this Desmos Scientific in the chat. May need that for this problem here. On the right, it is 81 plus 9z.
Where did you get the 14 from? Oh, part.
Right there. Yeah, the part. So the part is, I think they call it like tangent, but I prefer part because it's the first sequence of it. If you don't like that word, I mean, maybe go with something different.
And then that's 9 plus t in the parentheses.
9 plus z.
Oh, z. So 14 times 18. 252 minus 81.
This one doesn't work out nicely.
I got 19.
Oh, it does? Oh, I used the wrong number. That's why it doesn't work out nicely, because I made a mistake. Yes, Z is 19, but is that what they want? Is that what they're asking for?
No.
No, you got to go back in and
SU. So 28. Nice. So
okay. New types of problems here, 25, 26. Let me snip that one in here. All right, so unfortunately, 25, you do need an equation to do this. So the standard form of a circle is x minus h squared plus y minus k squared equals r squared. And h and k are the center. So h is literally -3, k is 6. So that's x minus -3 squared plus y minus 6 squared. Okay, now to this business of getting r squared.
Wait, H's.
H is -3, so the two negatives make a positive.
And then how do we know which point to choose? Which
So this is the center. The h comma k is the center.
oh,
Always.
okay.
Always.
So
That's
that'll
part of
just be given.
maybe. I mean, and this probably if it's like this, yeah. There's other problems where it's not given or it's kind of different. So if it says that it passes through this point, that means that point is on the circle. Like if you can think, you know, what does this look like? There's a, I'm gonna say this. Wherever your circle is, the center is here. This other point is on it.
Mm-hmm.
Okay. Now you can actually nicely find the distance by just counting, but normally you have to use the distance formula. Okay.
Yeah.
So do you know if you guys were talking about that in class or that's
Yeah, we
come up?
were.
So what we should do that for this problem, even though it's kind of overkill, but it's maybe going to help you in a future problem. So x2 minus x1 squared plus y2 minus y1 squared square rooted. All right, so you can think of
pull up my notes real quick.
Yeah.
I have it there. Okay. The distance. Oh, and no, we're using both.
Yeah, we're gonna use both coordinates and you put them into the formula here. So you do have to know that. So it'd be like 0 minus a -3 squared plus 6 minus 6 squared square rooted.
Zero. So 9 plus 0 squared?
Yes.
Okay. So 0.
Not 9 plus, yeah, 9. So it's the, you had it correctly, but you got to keep going here. So it's the square root of 9 plus 0 or
Mhm.
square root of 9, which is
3.
3. So that distance is um, the radius.
Oh. So then R, the radius, or so
It
it'd
is
be
the radius.
9.
It's the value of r. Yeah. So r is 3, r squared is 9. So you have to put that back into this formula.
So the whole equation would be x plus 3 squared plus y minus 6 squared equals 9.
Yes.
Okay. Cool.
All right. So number 26. Grab a
Take the
snip of that.
coordinates, the center, measure the radius, and graph the following equation.
All right, so let me write the standard form underneath of it. X minus h squared plus y minus k squared equals r squared. So you have to identify h, k, and r. Now I'm gonna tell you that the way most students remember how to find h and k is it's the opposite of what's inside parentheses. So if it's 4, that means h is -4.
Uh-huh.
If it's -2 inside parentheses, that means k is +2. Is that clear? How to find that?
Could you repeat it?
Yeah, it's most students go and they use the opposite of what they see. So if you see +4, they know that it's -4. If it's -2, then that becomes +2.
Okay. So h is -4, k is 2.
What is the value of r? What number, when you square it, gets you to 16?
4.
4. So to graph this, you start at the center. The center in this case is h comma k,
So
-4
-14.
right there. Okay. All right. And to graph the rest of the circle, use the radius and you go up 4 from the center, down 4 from the center, right 4 from the center, and left 4 from the center.
For the radius.
Yeah, because you're going to create a circle tracing through those 4 points there. Up, down, up,
Okay.
down, up, down, left, right.
So
And then you just smoothly try and connect them so that it looks as much like a circle and not like a football.
okay, that makes sense. So this way, 1, 2, 3, 4. This one.
Is that okay? Can we go on to 27? Maybe we're already there.
Yeah, sorry, I'm just grabbing a compass.
Okay.
Sorry.
Well, you're really going all out if you're grabbing a compass. That's almost
Yeah,
never hear a student do that anymore.
our teacher's really old school.
Yeah, well, I mean, good thing you didn't take a boat to Japan. That would have taken a long time.
So 27.
Yes. So this one, it looks like maybe it's a graphing or something, but it just has to find the point of intersection between the two. So a circle and a line have the following possibilities. They can miss, they can hit in two places. They can also be tangent where there's only one solution. And we don't really know which one it is until we do this. So this is what's called a nonlinear system. And you always solve these until you know otherwise by substitution.
Okay.
Which means you're going to take this minus x plus 2 because it's solved for y and replace in y. So let me know when you get up to this place here. We can talk about what to do next.
Replace in by substitution. So x squared plus negative x plus 2 squared equals 2. Okay.
Okay.
Or x.
So the correct way to proceed from here is to write out minus x plus 2 times minus x plus 2 and not to try something else that you might think is correct. And you will FOIL this.
Okay.
Okay, so minus x times minus x, that's x squared, positive. Minus x times 2 is minus 2x. 2 times minus x is minus 2x. 2 times 2 is 4.
So
from here, you do combine like terms. So it'd be 2x squared minus 4x plus 4 equals 2. You move the 2 over by subtracting 2.
So it's going to be equal to 0.
Yeah. So you got 2x squared
Minus 4x plus 2 equals 0. And then
So this is, you don't want to factor quite yet. Notice everything is divisible by 2. So you can actually factor 2 out of everything. Like that. And this will help make the factoring easier. If you don't do that, you might go down a rabbit hole and wish you had spent a little more time looking at it, see if a GCF factored out.
greatest common factor. I'm going to make a note of that.
Okay.
Factor. Okay.
So the greatest common factor 2, it doesn't contribute to the solution, and that's why I've kind of rewritten it so your focus is just on what's inside parentheses. And so you're now looking for two numbers that multiply to 1 but add to -2. So for example, 1 times 1 is +1, but does that add to -2?
No.
No. So the other possibility is that they're both negative. Is -1 times -1 +1? Yes, it is. Does it add to -2? Yes, it does. This becomes x minus 1. X minus 1 equal to 0. Your two solutions are 1 and 1. But that's not the final answer. Like you get this far, you got to be careful. It's like, what are we even doing? You know, it's 1, but you're going back. You're finding the point of intersection. So you need both x and y.
Jeez.
So you choose one equation or the other. We'll choose that second one. If x is 1, y is minus x plus 2. Minus 1 plus 2 is +1. So this is actually that blue case where there's only one solution.
Sorry. Can you go back to the
Down here at the bottom?
Yeah, down here.
Yes, yeah.
So the blue writing is just to
Just
make it
part,
easier to.
yeah, kind of to digest there.
And then we got x minus 1 times x minus 1 by doing that little tree.
Yes.
And how did we know what number to make the tree out of?
The number on the right.
Okay. Like the whole number.
Right.
Or the
The one on the right, the
one
constant.
without the x. Okay. And then it's always going to be the
Two numbers that multiply to the
we're
one on the
adding
right,
up to
but to the middle number. Yeah.
the middle number.
And we can do some practice on that.
2 factors of the one on the right that add up to the middle number. Let me copy that. One, negative one. And then okay.
All right. Any questions on that? Got to go back and take that one and put it back into one of the other equations, one or the other here to get the y value.
Mm-hmm.
Doesn't matter which one. They're both good. Both work.
Y equals 1. So we know x and we know y. And both x and y are 1.
Yes.
Now,
And that's it. You don't have to graph it. You just have to find the point of intersection.
oh, 1, 1.
Yep. That's it.
Cool. Okay.
Is there anything else to look at today? Got a couple minutes left here if you want it.
Yeah. Let me try and find a problem like the one we just did.
Okay.
I can't seem to find a problem like
That's okay.
going
I mean,
to,
we're really coming up here against the end here. If you want to
yeah.
though, maybe send over what you want to work on tomorrow. That way it's ready to go.
Oh,
Text or email or, whatever. So,
that sounds good.
if you find it, you can always send it over at any time. Happy to look at it. But that is it for us. Let me go ahead and stop the recording here.